We're going to look at compound inequalities today. What a compound inequality is, it's two inequalities smashed together to make one ugly looking problem. And I think this is pretty, that's what we're going to be dealing with. So before we get to something like this, let's break it down into pieces. So first off, we know how to graph this top one, x less than 7. We know that at the 7, there's going to be an open circle. Why an open circle? There's no equal sign, okay? X is less than, X is smaller than 7. What's a number smaller than 7? 6, 5, 4, negatives, all those numbers to the left, okay? Let's look at the second one. This time I'm going to change colors. I'm going to use a red one. Now, at that 3, open or closed, well, do we have an equal sign? Yes. That means we're going to have a filled in closed circle. We're going to color that in. X is larger. X is greater. What's a number bigger than 3? 4, 5, and 6. Everything to the right. Now, we're going to take these two answers, kind of put them together on one graph. Compound means just more than one on one graph. So let's take it in pieces. First off, I want to look at this. We just did that. My answer was right up here. So I can graph that, and I'm going to graph that. So the same way, do that. And I'm going to just kind of shade a little differently. Instead of squiggles all the way over, I'm just going to put a line. Okay. Now, let's look at this part of the problem. So this is very similar to what we have here. It's actually the same thing, just mirrored. So notice that this inequality symbol opens up and it eats the x. Down here, the inequality symbol opens up and eats the x. All we did was flip the whole problem. So I could take this and I could rewrite it if I wanted to. I could say x, then 3. I know that this opens up and it eats the x. I'm going to continue to do that. Now this is the same thing we have up here. And we already know what that graph looks like. So at that 3, we're going to do a closed circle. And this time we're going to shade everything to the right. And you get something like that. Now, when we're dealing with compound inequalities, I've got two problems here. My answer is saying I want this and that to happen. Where on this graph do I have this and that? Where do I have two things happening at the same time? Over on the left, I only have blue happening. All the way to the right, I only have red. Where do I have both? Right in the middle. That's going to be my answer. So when I shade these, now I'm going to kind of go and make it nice and messy in the middle. And everything to the right, I don't need. Everything to the left, I don't need. My graph says it is 3, and this number is bigger than 3. And it only goes up to, but not including 7, because there's that open circle. So what's happening? I've got a wall. That wall is 7. I'm creeping up to it as close as possible, but never touching it. That's what that shaded region is doing. Now, let's take this thought process and apply it to this, okay? Well, how do we do that now? Well, you know how to solve an equation. You know how to solve two equations. We're going to do two equations at the same time. How to get through that? Well, remember, whenever we look at the equal sign, it's always do something on the left, do something on the right. We want to do the same process, but instead of doing left and right, I'm going to break my problem down into left, center, and right. And my goal is to get the variable alone in the center. So this is what I'm focusing on, the middle here. Okay, if I'm focusing on the middle, I've got multiplication, I've got addition. What's the first thing we need to do in order to get away from x? We have to take care of addition and subtraction. So I'm going to do my inverse of that -4. We know that's got to happen. But what about on the outsides? What about the left and the right? We're going to do the same thing. We just happen to do it 3 times instead of twice. Those cancel. And we simplify and bring everything else down. Okay, what's stopping x from being alone? We got that -7. I want to divide by -7. Divide by -7. All right, we cancel x, we're left with -2 and +1, negative, negative, positive. Now, why didn't I write my inequalities here? Because something else special happened that we know. What did we divide by? A negative. If you multiply or divide by a negative number, we have to flip the inequalities. We even have to do that here too. So I'm going to flip this. So let's bring this, changes, we now get a greater than. Let's bring that down, and that's going to flip. Okay, one more small little step. Whenever you're ordering your numbers, you always want to have small number to large. That's how we read. Here I have large to small. So let's flip the whole problem. -2, x, 1. Okay, take it in pieces. At the 1, our inequality symbol opens up and it eats the 1. It opens up, eats the 1. At the 2, we eat the x. I want to make sure that this still eats the x. Okay, let's graph. -2, 0, 1. All right, at the 1, we'll start easy. We know we're going to have a closed circle. X is less than x is smaller than 1. We're going to go everything to the left. With the 2, I don't really like that order, so I'm going to switch it to make it a little easier. I'm going to say x, -2, we open up and eat the x. Cool. Isn't that what we just have right here? Yes. Now it visually makes it a little more sense. Open circle. X is greater than -2. X is bigger. Where do we have bigger numbers? Everything to the right. Where do our two problems overlap? Right in the middle. We do not need the left side extra. We do not need the right side extra. Our answer is everything in the middle. So it says -1 or +1's an answer. 0's an answer. -1's an answer. Is -2 an answer? No, it's not filled in. It just says everything creeping up to that wall is getting closer and closer and closer, but it's never touching that -2 wall. All right, over here. Well, this problem looks a lot different than this. What this really is, this is something called an AND problem. And you've got two things happening. I've got red happening and blue happening. I want to know where red and blue overlap. Where they overlap, that's my answer. I got a special problem that says or. I care about where's my red answer or where's my blue answer. They don't need to overlap. I just need one or the other to happen. So first one, let's do it in blue. I need to get x alone. So inverse operations, -1, -1. We get 3. The second side I'm going to do in red. Inverse operations, we're going to add x greater than or equal to 4. And now let's graph this. So I just got my numbers in order. 3. I'm going to have open circle, closed circle. Well, there's no equal sign, open. X is less than, x is smaller. Where are smaller numbers? To the left. In red, are we going to have open or closed circle? Well, there's an equal sign. Closed circle. X is greater than, x is larger than 4. Where do you have bigger numbers? Off to the right. My numbers, my graph doesn't overlap, but that's okay. All I care about is where do we have an answer for blue or an answer to red? Is 0 an answer? Yes, it's colored in. Is 5 an answer? Yes, it's colored in. All I care about is one or the other. My answer's on this side, my answer's on this side, we're good. My answer's over here, just in the middle. That's compound inequalities.